Before the first thunder of giants, before the echoing footfalls that would divide eras, there was stone and silence and the burdened memory of earth. In the layered pages of rock, stratigraphy etched by heat and water and time, the story waits. Bones mineralized into testimony, footprints pressed like signatures across ancient mud, eggs cradled in sediments that once were nests, skin imprinted in fleeting traces of texture and pattern. Paleontologists rid this deep archive with the patience of historians and the rigor of physicists. They take the pulse of vanished climates through isotopes of oxygen and carbon locked in teeth and shells. They synchronize distant chapters by magnets frozen in cooling minerals. They triage the broken and scattered with taphonomy's careful logic. Out of this discipline rises an epic of life bound to Earth's shifting breath, an epic of the animals we call dinosaurs, whose origins were not explosions, but embers, stoked in a crucible of change. Begin at roughly 230 million years ago, late in the Triassic, when the world was an improbable stage named Pangaea, a single supercontinent stitched together by mountain belts and braided by long rivers. The climates of this world were not gentle. Monsoons marched in towering cycles across latitudes. Deserts sprawled with dune fields so vast they bordered shallow inland seas. Forests of conifers, cycads, and ginkgos anchored the wetter belts, while horsetails and ferns ringed floodplains that swelled and retreated with seasonal rhythms. The air, paradoxically thin of oxygen but rich in carbon dioxide compared to today, hummed with insects we know from wings pressed like lace into slate. Wetlands coughed up amphibians the size of boats. Reptiles ruled in many shapes. Crocodile-lined archosaurs with armored backs and sprawling jaws. Beaked plant-eaters armored in plates, cousins and competitors to what was about to be born. The earliest dinosaurs were not rulers. They were shadows at the margins, swift and light and easily overlooked. Their arrival is traced in red beds and braided river deposits, in basins split by faults as Pangaea began to breathe apart. In northwestern Argentina's Ishigualasto Formation, night songs of crickets once replaced by volcanic ash, we find them. Eoraptor, small and graceful with delicate serrated teeth. Herrerasaurus, longer, predatory, a hint of the hunter's arc to come. Panphagia and others, basal forms that carried the seed of the split that would define a dynasty. In Brazil's Santa Maria beds, they leave more fragments, vertebrae lightened by internal chambers, bones that grew fast, knit by fibrolamellar tissue, captured under thin sections and polarized light. This is how we know their pace of life, not from conjecture, but from growth rings like the echo of an ancient pulse. Footprints sometimes precede bones. In Poland and Morocco and the Newark basins of eastern North America, on slabs once mudflats, there are tracks attributed to Prorodactylus and their kin, small three-toed imprints, a hint that the lineage jogged across the world before it fossilized in skeleton. Even this is a measured claim, grounded in the geometry of toes and pace, stride length mapped to hip height, the biomechanics of motion derived from modern physics. We can say that before there were kings, there were runners. The earliest branches diverged into two great radiations. Saurischians split into theropods, predators of narrow hips and bladed teeth, and sauropodomorphs, whose story would arc toward the longest necks ever raised on land. Ornithischians, with their forward-leaning tooth batteries and distinctive bird-hipped pelvis, began humbly as nimble omnivores nibbling under conifers in the edges of feeding grounds dominated by other reptilian powers. Pisanosaurus, perhaps among the earliest of them, is a scattering of bones and probabilities, a whisper of a body plan that would, over millions of years, flower into armored tanks, horned phalanxes, and the great beaked herds. In Lesotho and South Africa, tiny bipeds like Lesothosaurus dart through the early Jurassic dawn, leaving delicate tracks beside the broader tread of their long-necked neighbors. In the Triasic's waning chapters, dinosaur cousins held the crown of terror. Phytosaurs with crocodile faces but nostrils retracted between their eyes lay still in shallow streams and surged with sideways blasts of water to seize fish and unwary prey. Rauisuchians, thick-limbed and iron-mouthed, stalked the conifer groves. Etosaurs, armored like living barricades, plowed the forest floor for roots and shoots. On floodplains that would harden into the Chinle Formation of the American Southwest, petrified logs still glow with silica. In those same beds, Calophysis, a slender theropod scarcely heavier than a wolf, once found water during a dry season and gathered in numbers. We know because a flash flood stacked their carcasses in a tangled mass at what is now Ghost Ranch, New Mexico. Whitaker Quarry's bone bed, limbs and ribs and skulls, layered like cords, speaks of death by crowding and chance, but also of life in groups. Whether they hunted in packs or cached in the same environments, behavior is a cautious map we draw with bones, but the pattern rhymes. On the far side of Pangaea, in places that would be Ghana, Morocco, and Germany, long-necked Plateosaurus browsed on high. It is called a prosauropod in older books, but we know now these were early sauropodomorphs, an experimental stage in a lineage feeling its way toward gigantism. Their hips were sturdy, their hands sometimes turned inward for quadrupedal support, sometimes freed for grasping. Their intestines, inferred from barrel-chested ribs and the chemistry of coprolites, could ferment tough plant matter under the cool shade of araucaria-like conifers. Their trackways, pressed in soft ground and lithified in names like Otozoom, carry the weight of bodies that tilted the balance of ecosystems. When their feet stepped, they stepped with a rhythm we can listen to through the spacing of depressions, not the frantic skitter of a small predator, but the drumbeat of mass. The sky, too, had learned a new trick. Pterosaurs, born of another branch of archosaurs, took the air in the late Triassic. They were not dinosaurs, yet they shared the stage and sometimes the food. Eudomorphodon from the Alps shows a wing stretched on a finger so elongated it reads like a myth, the membrane spidered with fibers to resist buckling. Their bones are so thin, it is a miracle of preservation that any survive. Yet footprints, made by hands and feet in tidal flats and lagoons, reveal how some of them walked with curled fingers and placed their weight with the leverage of engineers. Dimorphodon would come later, Cryodracon much later still, but from the start, the sky was a competing realm where air became habitat, not just weather. Beneath waves, none of these were kings. The seas of the Triassic and early Jurassic belonged to different empires. Ichthyosaurs, sleek and dolphin-like, with eyes like planets. Long-necked nothosaurs, slipping through shallow shores. Later, plesiosaurs and pliosaurs sliding into the vacant waters left by extinctions. Ammonites and belemnites kept time with their tight spirals and bullet-shaped guards, their isotopes archiving temperature and salinity as the currents changed. Marine sediments preserve an honest ledger: black shales where oxygen was scarce, limestones where reefs pulsed, the occasional layer of ash that gives us zircons to date with uranium and lead. All of this is cross-checked. Paleomagnetism ties strata to reversals etched in the world's own iron memory. Pollen and spores wash through layers, marking floral shifts with the insistence of seasons. The Triassic ends with fire. Around 201 million years ago, the planet cracked along newborn fractures as Pangaea began its long breakup into continents that would drift to the lineaments we know. The central Atlantic magmatic province bled basalt in volumes beyond human imagination, step after glowing step, across what would be North America, Africa, and Europe. The climate convulsed. Carbon dioxide spiked. Carbon isotopes fell in signatures recorded by shells and wood. Forests withered and changed. Oceans flirted with anoxia. In the fossil record, this is a boundary defined by loss. Many crocodile-lined archosaurs disappear. Large amphibians yield their fresher waters. Some marine lineages blink out and are replaced. Dinosaurs, small and quick and physiologically poised toward high growth and perhaps higher aerobic capacity, slip into the spaces left by the fallen. It is not triumph in the conventional sense. It is survival that becomes ascendance. On the fresh shores of the early Jurassic, the world regreens. Continents crack along lines that will become the Atlantic, creating rift valleys with long lakes. In the Newark supergroup basins, the rhythmic beats of climate cycles are preserved in lake varves. Thin, repeated layers, like lines on a living thing's shell. Their thickness undulates with the gravitational clockwork of orbital cycles, allowing us to read seasons in stone. Dinosaur footprints run along these margins, Grallator and Eubrontes, three-toed tracks with clean, assertive geometry marking theropods of varying size. Beside them, pterosaur hand and foot sets stride along shorelines, proof that even limbs that flew learned to walk. On land, diversity blooms. Theropods gain complexity and presence. Dilophosaurus strides across what will become Arizona, its double crest a flourish of bone that may have been display as much as structure. Pneumatic cavities hinting at air sacs that lighten the skull and speak to a respiratory system more like a bird's than a lizard's. In Antarctica's frozen deserts, where light now comes slantwise and ice writes its own scripture on cliffs, there is a ghost of Jurassic forests, and Cryolophosaurus moves among them from a time when the continent lay closer to temperate latitudes. Its crest, too, is a banner of bone. Each of these skull ornaments is an invitation to hypothesize about social behavior, sexual selection, visual signaling, hypotheses constrained by the mechanics of bone and the comparatives of living animals. Sauropodomorphs push further toward the monumental. Mosaspondylus traverses the early Jurassic of southern Africa, its neck longer, its limbs inching toward a quadrupedal inevitability. The story is told not only in adult bones, but in eggs. In the lower Elliott Formation, clustered nests, each with a dozen or more elongated shells, no larger than a human fist, are arranged in what look like colonies. The embryos inside, preserved at levels of detail astonishing for their age, show bone proportions that imply hatchlings walked differently from adults, perhaps more upright, perhaps dependent on parental care in a way dinosaur myth never allowed. There are growth rings in their bones, lines of arrested development that map seasons of scarcity, and the nests stack across multiple levels of sediment, suggesting site fidelity, a return to safe ground across generations, recorded by layers of sand and silt, and the ghosts of footprints pressed by parents who did not know they were writing. In North Africa and island fragments that will become Europe, new sauropods emerge, volcanodon steps with columnar legs in Zimbabwean rocks. Tazutosaurus in Morocco places its feet with the deliberate poise of a lineage committing to size. Trackways widen, handprints become full, not just the imprint of a thumb claw. Vertebrae balloon with internal chambers that lighten the neck like a cathedral's buttresses mid-air. We understand the engineering, torsional stresses dissipated by ligament systems wound along spines, pneumaticity coupled with a circulatory push that had to lift blood to heads high above. We can model blood pressure and infer hearts with multiple chambers. We can trace air sacs in cavities that reduce bone density while stiffening the skeleton. These are deductions disciplined by physics and physiology, but they play out on a stage of ferns and riverbanks where low clouds move and insects pulse in warm air. Ornithischians, those quiet beginnings, begin to arm and diversify. In the early Jurassic deserts of what is now the American Southwest, Scutellosaurus scurries, a small animal with rows of dermal ossicles like a test pattern half-formed, the ancestral echo of armor that will soon harden into the ramparts of ankylosaurs and the plates of stegosaurs. In coastal Britain, Solidosaurus walks with a heavier gait, hedging its bets with both armor and speed, its tail a lash backed by muscle that leaves credible marks in trackways. Heterodontosaurus, quick and toothed like a Swiss army knife, bites across the menu of its environment with enlarged canines for display or defense and chisel-like cheek teeth for shredding plants, an omnivorous ambiguity written in enamel and microware. These are not yet the horned storms and hammer-tailed fortresses of later times, but the blueprint is visible, the logic of defensive innovation shaped by the predators that pace beside. From the texture of bones, we read metabolism. Vascularized, woven fiber cortices testify to rapid growth. In theropods, hollow shafts and thin walls speak to weight saving for speed and, in later forms, for flight. In sauropods, the rigidity and pneumatic architecture argue for mass and airflow, for an animal that stays aloft, not in the sky, but in the economy of biology. Histology becomes poetry in numbers. Growth curves that cross-check with body mass estimates derived from femoral circumference, isotope analyses of carbonate in bone that straddles temperature and water sources, the ratios of oxygen that whisper if blood ran hot. The evidence leans toward high growth rates and active thermophysiology in many dinosaurs, a gradient from the reptilian past to the avian future, a bridge crossed in increments and experiment. The plants answer in kind. In sediments where dinosaur teeth and eggshells gather, there is a rain of pollen and spores. Conifers dominate uplands. Benetitalians and cycads dot the midlands. Ferns reclaim floodplains after fires, their spores spiking in a pattern paleobotanists call a fern spike, nature's seal of return after catastrophe. The grasses we know are a distant dream. Ground cover is low and patchy, food to be gathered with patience or filched with speed. Stomatal density in fossil leaves tracks the breadth of the atmosphere, each tiny pore a record of carbon dioxide tension, the mouths of plants opening wider or closing tight across time. All of this is the matrix in which dinosaurs forage, compete, live. When we reconstruct their worlds, we do not draw silhouettes on blank paper. We color them with climate maps, with runoff models, with the distribution of lake fossils that say where there was water and how long it stayed. In this chapter, the birds are not yet birds, but their shadows lengthen. The lineage that will eventually become avian is in the theropods, in small forms that refine their wrists, reduce their tails, and lace their bodies with air. The furcula, the wishbone, appears in some. Feathers, at first simple filaments, will soon elaborate into veins and pennaceous arrays for insulation, display, and eventually flight. There are hints in the early Jurassic, filamentous integument in relatives and precursors, the architecture of arms tending toward a stroke, but the full feathered choir will rise in the Middle and Late Jurassic. For now, it is the drumbeat of steps and the line of footprints that tell us a story. Grallator tracks, 3 toes, and a thin rear pad show the stride of animals that carry their weight over hips, tails acting as counterbalance, a living physics demonstration running across a damp shore. Across ecosystems, the choreography is complex. Rivers shift course, leaving oxbows and meanders stuffed with bones. Dunes march, preserving crisscrossed laminae where only the lightest creatures leave a memory. Lagoons trap carcasses and scatter them through storm layers in pieces that must be reassembled. In the mud of an ancient nesting ground, the same space plays nursery again and again until the sediments stack like albums. Taphonomy intervenes, making every narrative contingent. We listen to what preservation tells us and what it hides. Delicate bones, rare because they broke. Eggs with shells that disintegrate unless the chemistry is right. Skin impressions captured only when the exact pressure and moisture collude. Yet even in their absence, the shapes of lives emerge. The early Jurassic apex is not yet the roar of sauropods that blot out the horizon or the saber-toothed beaks of ceratopsians that will one day thunder across floodplains. Instead, it is a multiplied variety. Small predators course through underbrush with the cool efficiency of design honed by survival. Mid-sized hunters pace ridges, their crests proclaiming identity and intent. Browsing sauropodomorphs use reach and quantity, cutting leaves with simple teeth and trading chew for gut. Armored ornithischians test stones of bone beneath their skin, finding the arrangements that help against bites and strikes. Above, pterosaurs in early forms ride thermals that rise off warm stone, their wings mapping the invisible topographies of air. In the sea, the lacquered eyes of ichthyosaurs take in light from depths that swallow it. The world is a layered assembly, a trinity of land, sea, and sky, braided by cycles that we detect in isotope curves and sediment packages, and by the way bones come to rest. In the laboratories where these fragments arrive, the story is revisited on new terms. Radiometric clocks tick with the decay of uranium to lead-in zircons lifted from ash beds, interleaved with dinosaur-bearing strata, anchoring ages down to tens of thousands of years. Magnetostratigraphy crosses continents by matching sequences of reversed and normal polarity captured in iron minerals when they cooled. High-resolution CT scans glide through stone, exposing sutures and sinuses, peeling back the skull to reveal the architecture of senses, where the inner ear's loops might have tuned balance and head movement, how the olfactory bulbs may have swelled in a nose that knew the world by scent. Stable isotopes extracted from enamel follow water signatures across landscapes, hinting at migration. Microwear on teeth reads like a diet diary, scratches versus pits, brows versus grit. Eggs whisper in crystal, their pore systems speaking of gas exchange and nest burial, their thickness calibrated to the loads of parent and substrate. When we speak this knowledge aloud, when we give it a voice and cadence, the world we describe is not a fantasy. It is a disciplined imagining anchored to numbers and layers, to bones that break and bones that heal. Yet it is not dry. The breath of this saga is the sway of cycads beneath a hot wind, the call of an insect that will never sing again, the first crack in a shell as a wet snout meets air, and the first heartbeat that is not buffered by a mother's body. Across the Triassic and into the early Jurassic, a lineage learns to be many things: hunter and giant, armored and swift, runner and sitter of nests. They are not inevitable. They are contingent, shaped by catastrophe and opportunity. What begins as a whisper in red beds swells into a chorus. Their feet press the wet edges of lakes, and those impressions dry into stone. Their ribs fall to floodplains and settle in silt that, compacted, remembers their breathing. Their eggshells in quiet hillsides cradle the embryos of futures they will never see. In the rhythm of geologic time, pulses quicken where magma meets sky, then settle into green again. When the fires of the rift had dimmed and the basalt cooled, the world that rose from the Triasic's last convulsions was not a blank slate, but a palimpsest. The signatures of catastrophe, ash in lake beds, fern spikes in pollen records, the sudden silence of vanished lineages, were overlaid by a new script written in bone, track, and wind-sculpted sand. The continents, once locked in a single brooding mass, began to drift like rafts upon a convecting mantle. Seas crept into torn seams, monsoons softened, coastlines multiplied. The stage broadened, and with it, ecological space. In this widened world, the small, swift, marginal players of the late Triassic stepped into the open and grew vast. The early Jurassic carries the hush of rebuilding, on floodplains braided with rivers, and among gymnosperm forests heavy with cones and resin. Survivors assembled new guilds. Our ledger for this time is written in the ruddy sandstones of the Kayenta and Glen Canyon, in the marls of Lufeng, in the desert dunes of the Navajo, and the tidal flats of Morocco. There we read delicate tracks that cross and recross like signatures upon damp parchment. Theropods three-toed and precise, early sauropodomorphs with inward curved metatarsals, even the belly drags of creatures pausing to rest, all preserved beneath the indifferent weight of accumulating strata. Often the tracks precede the bones. Where bodies fail to be entombed, footsteps speak, and their language is the map of behavior. From among those traces, we watch the sauropodomorphs, once graceful and bipedal, commit to a path that will make them titans. Their skeletons, sampled by histology, thicken with fibrolamellar bone, a tissue grown in haste, vessels walled in by scaffolds of mineral, a billboard of high metabolism. Vertebrae develop cavernous interiors, a honeycomb of air, the stamp of pneumatic invasion, by a branching system of sacs connected to lungs, the same engineering that today lightens a bird's chest and fuels unrelenting breath. In the early Jurassic of China and India, Lufengosaurus in the east, Barapasaurus in the south, embryos and juveniles show a tempo of growth that would strain any slow-living reptile. In Morocco and Tanzania, names like Tazutosaurus and Volcanodon signal the threshold crossed. True sauropods, forelimbs stout, necks elongate, tails already balancing arches of vertebrae as they take to quadrupedal life. By the Middle Jurassic, the geometry of the land changes further. Rifts widen into nascent oceans. Islands and peninsulas punctuate shallow seas. Climate gradients stencil themselves across the globe. Conifer stands of Araucarias tower in the south. Ginkgos fan leaves like hands in breeze. Cycads and Benedictalians anchor the understory. The air is warm and, in many intervals, rich with oxygen. Fires flicker through forests, and in the charcoal of ancient soils, we read intervals of drought and lightning. In this greenhouse, the dinosaur clans diversify with surgical precision, each lineage carving a niche in an expanding web. Sauropods, the architects of the giant herbivore niche, branch into multiple dynasties. In Africa and what is now Germany, forms like Shunosaurus carry club tails and deep barrel bodies, a hint of experimentation. In the late Jurassic, with the Morrison Formation spread across western North America and the Tendaguru beds spanning the edge of an African sea, we meet the giants with the clarity of a ledger. Diplodocids, Diplodocus, Apatosaurus, extend their bodies into pulleys and cables, skulls small and horseshoe-mouthed, teeth pencil-thin and worn by shearing, necks long as river bends, and whiplash tails that could have cracked air. Camarasaurids bear broader snouts, heavier teeth, robust heads. Their bite marks on petrified wood and leaf impressions suggest a different diet, a different reach. Brachiosaurids, Brachiosaurus in North America, Giraffatitan in Africa, stand like living cranes, forelimbs taller than hind, shoulders a high horizon, necks hoisted vault-like into the canopy. The distribution of their trackways, narrow gauge paths pressed into tidal muds and lake margins, records how their limbs marched in column, their mass spreading into the substrate. These paths thread across continents as if herds drifted seasonally along remembered routes, seeking floodplain greens and the margin shade of conifers. How could flesh rise to such measures? The evidence gathers in bone and trace. Pneumatic vertebrae lighten necks without sacrificing strength. The foam of air chambers braced by struts of calcified trabeculae. Ligaments as broad as hands anchor along spine and pelvis, ossified in life to become the stiff sheets we find in the quarry. Growth rings in long bones, akin to tree rings, but recording pulses of abundance and stress, show that many giants grew rapidly to near adult size within a handful of years, and then maintained bulk through steady deposition. Teeth, counted and measured, reveal replacement rates in weeks, rather than seasons, a conveyor of enamel and dentine keeping pace with the abrasions of a plant-rich diet. Coprolites, the fossilized end of a meal, carry the fragments of ferns, conifer needles, and horsetail silica. Their chemistry records gut passage and bacterial work. Gastroliths polished smooth by tumbling in stomachs confirm that stone was recruited to grind where molars never evolved. Around them, predators refined their craft. Theropods, once small and fleet, radiated into forms that controlled the top of the food web. Ceratosaurus, with nasal horn and a deep, notch-toothed skull, stalked river margins. Megalosaurus and Torvosaurus, early rulers of the western Pangaean archipelago, carried the old design forward with brute strength. But in the Morrison beds and equivalents across the globe, the Allosauroids rise. Allosaurus, lean and muscled, swivels its binocular gaze over the bone-banked valleys. Its skull, latticed with fenestrae, is not a battering ram, but a kinetic frame. Its bite is not crushing, but swift. In the Cleveland Lloyd Quarry, a predator's paradox lies in drifts of bones, where Allosaurus remains dominant, intermingled with sauropod ribs and stegosaurs plates. The chemistry of the sediments and the mix of ages suggest a trap of mud and thirst, or a mire that lured hunters to scavenge and stay. Here, tooth-scarred bones bear the signatures of feeding. Healed lesions on ribs and vertebrae speak of life after collision and bite. Do the patterns whisper of coordinated assaults? The ledger is cautious. Trackways show groups of theropods moving together, but the trace is not testimony enough. Perhaps they gathered at water or followed the same pathways carved by landscape's constraints. Yet there is no denying their reach. Furculi, the fused clavicles that in birds anchor flight muscles, arch in their chests, early evidence of shared architecture. Air sacs infiltrate their skeletons, hinting at a lung with the efficiency of a bellows-like flow. Their bones, too, carry the fibrolamellar stamp of rapid growth and elevated energy budgets. Even armored herbivores adapt to the pressure. The stegosaurs, strange ships of plates and spikes, pace the late Jurassic floodplains. Stegosaurus carries a double ladder of plates along its spine, thin bony sails pierced by canals and grooves. Whether for cooling, for display, for species recognition, or all at once, the vascularized surfaces suggest blood once warmed them or colored them bright under the Jurassic sun. The tail ends in a quartet of spikes, the thagomizer, whose punctures in theropod bones change speculation into encounter. Their heads are small, their teeth simple. They crop soft vegetation and move deliberately, and yet the skeletons tell of powerful hindquarters and a tail that can whip with force. Ankylosaurs begin as murmurings in the record, their early kin nodosaur-like, dermal armor erupting in plates and studs that would, in time, build to tanks. Ornithopods, Dryosaurus, Camptosaurus, are fleet-footed grazers and browsers with battery-like rows of teeth that hint at the future dominance of their clade in later times. In Asia, delicate animals like Calindodromeus carry filaments, simple feather-like coverings that blur the boundary of integumentary innovation. Feathers, once thought the exclusive property of theropods on the line to birds, now appear as a shared heritage of dinosaurs more broadly, varied in form from bristles to veins. Beyond the forests, the seas write their own chapters. Along the cliffs of Holzmaden in Germany, fine-grained shales record a quiet basin deprived of oxygen at depth. Into that darkness fell the bodies of ichthyosaurs and plesiosaurs, the reign of their remains sealed before scavengers could discriminate, their outlines preserved right down to skin impressions and the curve of unborn young. Stenopterygius and Ophthalmosaurus glide through this record with enormous eyes ringed by sclerotic plates, vision tuned to twilight sea. Within their bodies we find embryos oriented tail first, evidence of live birth in the water, a convergence with whales yet to come. Plesiosaurs split into two extremes, long-necked plesiosauroids like Cryptocleitus with dozens of cervical vertebrae and tiny heads that search for shoals, and plesiosaurs with skulls the length of a man, like Leopleurodon, jaws hinged by mass and muscle for ambush. Ammonites, coiled like galaxies, populate the water column by the millions. Their shells, banded in growth, encode paleotemperatures in oxygen isotopes. Their rapid evolution provides clocks for the rocks themselves, letting us tie local stories into global time. Belemnites flicker by, coleoid kin that leave behind bullet-like guards. Reefs assemble, fall, and rebuild, not yet coral's full empire, but communities of sponges and bivalves and early scleractinians that shape coastlines. Above both, sky becomes an arena. Pterosaurs, born of Triassic innovation, saturate the air with form. Early in the Jurassic, long-tailed rhamphorhynchoids skim low over lagoons, their wing membranes stretched from elongated fourth fingers to ankles and flanks. The membranes, reinforced by tough fibers called actinofibrils, preserve in the Solnhofen limestones as faint veils around bones. Even their skin, furred with hair-like pycnofibers, imprints. In some, melanosomes, the pigment-bearing organelles, survive, letting us infer slate-gray or tawny hues. Tracks pressed into wet sand show that when grounded, they walked on all fours, wrists rotating to plant three-fingered hands while the wing finger kept clear. In the Middle Jurassic of China, Darwinopterus and its kin display mosaic evolution, long tails coupled with skulls and necks of advanced pterodactyloids, a modular remodeling that foreshadows the late Jurassic arrival of the true pterodactyloids, shorter tails, expanded heads, elongated metacarpals, and the rebalancing of the wing toward efficiency and range. In karstic lagoons of Solnhofen, Pterodactylus, Rhamphorhynchus, and their contemporaries fall into hypersaline traps and are embalmed by the quietest possible mud. There, a dragonfly's wing lies next to a feather, an ammonite next to a delicate lizard, the archive of a world preserved in breath-holding detail. It is in those same limestones that a singular animal bridges old boundaries. Archaeopteryx, the urvigal, offers a shadow of a bird where dinosaurs once stood alone. Its feathers fan with asymmetrical veins, the hallmark of airworthy flight. The furcula pinions the shoulder. The semi-lunate wrist bone permits the sideways sweep of a wing stroke. The tail, though still long and bony, carries rectrices like banners. Teeth grin from the jaws. Fingers end in claws. The breastbone lacks the deep keel of modern flyers. Is it a glider, a flyer, a climber of trunks that launches into canopy air? The skeleton is a compromise between earth and sky. Around it, in the Jurassic beds of Liaoning and the Daohugu biota of northern China, China clay sediments capture feathered theropods whose names, Anchiornis, Xiaotingia, flash briefly like sparks. Their plumage patterns, mapped by melanosomes, show mottled blacks and whites, rusted crowns, and striped limbs, an ecology of color in the undergrowth. These, together with Archaeopteryx, mark the coalescence of a suite of traits into an avian threshold. The respiratory complexity already present in theropod kin, the insulation of feathers, the metabolic intensity, the neurological architecture for balance and gaze, all align into a lineage that will survive when others fail. Landscapes change around them. The Morrison's layered sandstones and mudstones speak of broad, semi-arid plains with seasonal rains, meandering rivers depositing point bars, lakes that bloom and shrink. Tendaguru records both coastal and inland settings, dunes and deltaic lobes, nesting beaches and inland woodlands. Fragments of driftwood petrify, their growth rings whispering seasonality. In Portugal, the Lourinhã Formation preserves nests and eggshell microstructures, spherulitic in some sauropodomorphs, prismatic in others, each type a shell-building recipe encoded in calcium carbonate. In China, the Lufeng Formation's dinosaur embryos, little bones woven from fibrolamellar tissue, display lines of arrested growth that imply paleo-seasons of scarcity, followed by abundant warmth. The chemical breath of past atmospheres is caught in carbonate nodules and in the isotopic gradients of tooth enamel. The data, when plotted, sketch temperatures that rarely plunge, humidity that waxes and wanes with distance from coasts, and an overall world without polar ice caps, perhaps with forests creeping close to high latitudes. The Earth's engine never rests, and mantled plumes and subducting plates write their own marginalia. The Atlantic opens by centimeters a year, a pace that, given time, makes an ocean and maroons once neighboring ecosystems on different coasts. Yet for a span, land bridges persist. North America and Europe, Africa and South America, Antarctica and Australia connect and part, the pulses of faunal exchange reflected in twin lineages that mirror each other across seas. That is why a brachiosaur silhouette rises over both Wyoming and Tanzania, why stegosaurs parade across both Laurasian and Gondwanan shores, why small feathery theropods punctuate both East Asian and European margins. Provinciality subtly increases by the late Jurassic, and with it, the experiments diverge. Our sense of ecology deepens as the record grows granular. Microfossils, spores, pollen grains, diatoms dust the slides of paleobotanists, mapping vegetational belts and aridity gradients. Charcoal fragments in floodplain deposits tally ancient fires. Stable isotope ratios in bone apatite and tooth enamel plot water sources and trophic levels, the gradient from canopy to ground, from upland to lowland, from predator to prey. Tooth microwear under SEM reveals leaf versus fern cropping, the grit of a dry season, the shift in diet between juveniles and adults. Even the scars on bone tell stories. Healed injuries on a Stegosaurus plate suggest blood supply robust enough to mend a wound, while the pattern of growth marks in the plate's bone supports a mix of thermoregulatory potential and display function. Stress fractures in theropod phalanges betray a lifetime of impacts. Pathologies in vertebrae show the cost of long necks to sauropods, disease, arthritis, the wear and tear of mass. In this age, crocodile-lined archosaurs retreat from the topmost tiers on land, evolving into smaller, quick-footed terrestrial Sphenosuchians early, then into the Neosuchians that haunt rivers and coasts. Turtles broaden into marine grazers and terrestrial hulks, their shells stamped into sandstone along shores where once dune and surf collided. Mammals scuttle through the underbrush, not merely nocturnal insectivores, but already diverse. Docodonts with complex teeth, multituberculates, gnawing like archaic rodents, insectivores with fossorial habits. Their jaws and tiny ankle bones, exquisitely preserved in storm-swept bone beds and fine lake clays, proclaim a parallel saga, quieter now, but destined for a louder chapter later. As the Jurassic wanes, turnover whispers at the edges. Some ichthyosaurs begin to trend toward more fish-like forms. In the skies, pterodactyloids increase, their skulls crested, and their proportions suited to dynamic soaring over new continental shelves. On land, macronarian sauropods prepare for a Cretaceous bloom, while diplodocids wane, their lineage pruned as ecosystems shift. The first stirrings of angiosperms are so faint as to be arguable, but their prelude is present in the ecology. Insect lineages diversify, and mouthparts become more intricate, pollination relationships more possible. The sedimentary archives show rising seas in episodes, an inkling of the shallow epicontinental waters that will spread across continents in the next act. What does it mean to call this the birth of Titans? The archives answer not with fanfare, but with enumerated detail. In 2 centuries of fieldwork, we have quarried skeletons from mesas and dug eggs from arroyos, traced footprints along beach rock now lifted high, scanned vertebrae until their air spaces glow virtually in cross-section, and sliced bones to count the invisible races run by blood and calcium. We find skin impressions from sauropods stippled with pebbly scales. We ink the plates of stegosaurs to reveal the channels that once carried their life's warmth. We coax from Solnhofen's limestone the print of a feather whose asymmetry speaks of physics of lift. We extract isotopes from enamel and calibrate them against a living world to judge water drunk and leaves eaten. We map magnetic stripes on the seafloor and tie them to reversals in the rocks of floodplain and dune to synchronize local chapters into a global chronology. Each datum is a stitch, the cloth is an epoch, the pattern is the rise of a dynasty that sprawled across land, sea, and air. Yet the narrative is not blind pageantry. In the Jurassic, dinosaurs do not simply grow as if inflated. They engineer. Their skeletons are composite bridges of lightness and strength. Their metabolisms, inferred from bone histology and oxygen isotope spacing, taper toward warm-blooded strategies. Their reproduction, glimpsed in eggshell microstructure and embryo development, shows a spectrum of strategies, from buried clutches to possibly guarded nests. Their brains, surveyed by endocasts, reveal olfactory bulbs, in some enlarged by a hunter's needs, vestibular systems tuned to stabilizing massive heads or agile leaps. Their senses were not clumsy, but keyed to the demands of their ecologies. If the Triassic set the table, the Jurassic is the feast of adaptation, and there is continuity in the story. In the hollow of a theropod's vertebra, in the loop of an air sac, in the Y of a furcula, we see the line that will run unbroken across time's chasm into the wings that beat above our heads today. When we listen for dinosaurs, we listen for birds. The songs of sparrows and the flight of cranes are the living end of an architecture that perfected itself under Jurassic suns and storms. In their bones, we find not only mass and menace, but the refinement of an idea that life, given time and climate and space, invents worlds from the same handful of forms. The continents continue their slow estrangement. With the dawning of the Cretaceous, a new heat will settle upon Earth, and waters will rise into shallow seas that flood the interiors of continents. Titanosaurs will stride out of southern lands to replace their long-limbed cousins. The beaked ornithopods will proliferate into herds that stampede across mudflats and coastlines. Pterosaurs will stretch wingspans to the length of small airplanes, and among the coelurosaurs, feathers will flower into forms that preen and glide, and when the great forests of the late Jurassic bowed to a new sun, the world of the Cretaceous rose not as a single stage, but as an archipelago of theaters. The continents that had once been joined in a single colossal handshake drifted apart, their ragged edges torn into basins where shallow seas poured in. The air grew heavy with warmth and moisture, sea levels climbed. The Cretaceous greenhouse swaddled the planet in a damp, luminous haze. And in this radiance, new kingdoms formed of towering herbivores and armored bulwarks, of crested wanderers and quick-eyed hunters, of wings that sailed and wings that beat. Plants rewrote the ground rules, flowering and seeding with an urgency that reworked the diet of giants, and the winds carried pollen, dander, and the wingbeats of strangers to shores that had never known them. In stone, the story lies with a fidelity that defies time. The buckled strata of inland seas that rose and fell, the cross-ticked leaves and amber tears that trapped mid-flight insects, the prints of animals marching with purpose across dunes and floodplains, long before their bones joined them in the archive. Sauropods, the living ramparts of the Jurassic, did not fade with the old dynasties. They changed their banners and advanced. Diplodocids dwindled, brachiosaurids held on in patches, and from the southern continents, a new lineage ascended to rule the green world, the titanosaurs. Their necks and tails were the measures of horizons. Their skeletons were latticed with air, bone honeycombed to accept the breath of life moving through pneumatic corridors as in birds. Their legs were pillars that bore a continent's weight with slow, precise confidence. Wide-gauge trackways pressed into Cretaceous mudflats show the spread of their limbs and the breadth of their torsos, a rolling columnar gait different from the narrower paths of their older kin. Some carried bony shields beneath the skin, armored osteoderms like pebbles embedded in muscle, as in Saltosaurus, a granular armor for a colossus. In the Patagonian rock record, the names are cathedral bells, Argentinosaurus, Patagodoton, Dreadnoughtus, each a monument to the physics of growth measured in histological rings and Haversian canals. At Auca Mahuevo and other nesting grounds, whole hillsides of eggs testify to communal breeding and seasonal return. Nests arranged in quiet geometry, perinatal bones fragile as spun sugar, the echo of a titan's promise folded into calcite. But the leaf was no longer what it had been, and the crown of the canopy changed hands. In the mid-Cretaceous, angiosperms unfurled a new ecology, flowers competing not only for light, but for the loyalty of insects and wind. Their seeds offered concentrated packets of energy. Their leaves introduced previously untested textures and chemicals. Herbivores answered with technology of their own. Hadrosaurs, the duck-billed marvels of the late Cretaceous, built dental factories within their jaws, batteries of constantly replacing teeth that ground plant matter into paste. Ceratopsians crowned their skulls with frills and horns, keratin-sheathed armories for display and defense, their beaks clipping stems, their neck muscles bracing against the push and pull of combat. Across the floodplains of the western interior seaways margins, those inland waters that split North America into two, vast herds moved like rain clouds made of bone and will. Bone beds thick as peat preserved their collective fate. Centrosaurus, Pecorinosaurus, and the late sovereign Triceratops, their horns scored with scars, their frills pitted with the biography of a life lived among equals and adversaries. The hadrosaurs answered with crests that extended their voices. Parasaurolophus and its kin bore resonating tubes through which air moaned and trumpeted. To those who lived it, the plains must have rung at dawn and dusk with orchestrated calls. Predators were in no way diminished by the flowering of herbivores. In the north, the tyrant dynasty grew from small, agile hunters into a handful of colossi. Tyrannosaurus rex arrived late but decisive, the skull a fortress of thickened bone and interlocking struts, jaws capable of exceeding any bite force known on land, teeth like stakes. Histology preserved in cross-section reveals adolescent surges, a growth spurt that could pack a ton into a year, before maturity brought thickened bone and a slow economy of strength. Sensory fossils expanded olfactory regions, the anatomy of the ear, speak of a predator attentive to distant scent and low-frequency sound as much as to speed. The arms were short, but massive at the shoulder, still limbed and strong, a signature of a lineage whose power had migrated to head and neck. In the south, different banners snapped in the wind. Abelisaurids with stubby skulls and deep bosses, Carnotaurus with forelimbs more vestigial than thought possible, Majungasaurus with evidence etched into bone of cannibal bites, Carcharodontosaurids with blades for teeth that recall their shark namesakes, Spinosaurids, crocodile-snouted and fish-marked, their isotopes and bone microstructure, hinting at lives along and within the water, their skeletons adapted to a semi-aquatic waltz. No single empire of predators ruled the Cretaceous. Rather, the world was partitioned along the fault lines of ancient continents, each theater with its own antagonists, all of them written into sandstone and marl. Beside them, lighter feet scribbled the margins. Feathers, once a strange experiment of insulation and display, spread across the Coelurosaur tree, branching into forms that blurred the line between the earthbound and the airborne. Archaeopteryx, the banner carrier of the late Jurassic, was joined by hosts of Cretaceous birds and near birds, Confucius ornis with a beak and long paired tail streamers, Enantiornithines, the opposite birds, with their reversed shoulder joints and teeth, Hesper ornis, a powerful diver with stunted wings and backward thrust legs that carved cold inland seas, Ichthyornis, a gull-like hunter whose toothed beak presaged the modern order while still carrying ancestral armature. In oviraptorids and troodontids, brooding postures frozen in time, adults crouched over rings of eggs, arms spread in a protective embrace, reveal a tenderness as ancient as the shell. Oval eggs arranged in pairs whisper of two oviducts replaced by one. Medullary bone, a transient store of calcium inside mature females like a living dowry, has been discovered in theropods as ferocious as tea. Rex, showing a hidden link between predation and parenthood. Where skin impressions survive, the filaments and pennaceous feathers preserve microstructures of melanosomes. Under the microscope, they pair color to form, stripes, iridescence, camouflage, signals, the palette of survival afire within vanishingly thin relics. The air sac system, those same pneumatic highways that let sauropods breathe efficiently at a giant scale, ran through these smaller bones as well, a ventilatory engine that powered warm-blooded lives and buoyed flight. The sky, however, was not theirs alone. Pterosaurs had taken to the air long before birds were even an idea, and they perfected the art of wind. In the Cretaceous, they reached new extremes. Ajdarchids stalked coastlines and inland plains on limbs as tall as giraffes, their skulls long like spearheads. Quetzalcoatlus may have surveyed rivers from heights that beggar modern comparison. Pteranodon rode the stiff breezes of the western interior seaway, its toothless beak and long crest the profile of a consummate soarer. Soft tissue fossils show wing membranes, robust and reinforced, muscles working over a four-limb architecture built for both launch and flight. Egg discoveries with leathery shells point to a reproductive strategy more akin to reptiles than to birds. Flight was a life history, not merely a behavior. Pterosaurs and birds coexisted for tens of millions of years, dividing the aerial realm into niches of size, diet, and strategy. Far below, their shadows moved over an ever-changing mosaic of water and land. The seas themselves were theaters of overwhelming spectacle. Where the inland seaway divided North America, coastline curled and yielded to tropical shallows. In Europe and the Tethys margins, chalk was being laid, coccolith plates of microscopic algae raining into strata that would someday make white cliffs. Ichthyosaurs, titans of the earlier age, had vanished by the mid-Cretaceous, but plesiosaurs still paddled with long necks and smooth strokes. Pliosaurs, some with heads like battering rams, persisted in the early Cretaceous before yielding the crown. From the lizard lineage came a revelation: mosasaurs, marine squamates that turned their flexible bodies into engines, tails deepened into fins, flippers carved from once walking limbs. They hunted ammonites, whose coiled shells record mass extinctions as rings record winters, and fish whose bones preserve the geometry of streamlines. Sharks and rays multiplied into forms that would carry forward unchanged in outline, and teleost fishes, modern in their bones, jaws, and scales, came to dominate the open waters. In the reefs, corals shared space with rudest bivalves that built pillars and domes, strange shell architects of a short-lived empire. Every trophic rung was loaded, and every year the water warmed and cooled, laid down layers of chemical memory that geologists now read like ledgers. On land, the floras had moved on from cycads and seed ferns to flowering trees and shrubs, and with them came a renaissance of small actors. Insects proliferated into myriad roles. Bees appeared to partner with blossoms. Beetles took to shredding. Butterflies quietly painted the air. Amber, cured sunlight distilled from resinous tears, trapped life in exquisite detail. Within these jewels we see feathers aglow with iron red and soot-black pigment, ticks grasping dinosaur skin, flowers with pollen grains poised to begin a new family. The microfossil record of spores and pollen spikes and dips in response to fire and flood, drought and peace, each layer a paragraph in a saga written in dust. Where climate warmed the world, polar forests still rose at high latitudes, their rings tight from months of darkness and the return of milky summer light. Dinosaur bones and tracks lie within these paleotemperate circles, hadrosaur herds and small-bodied ornithopods whose eyes widened beneath the low sun, their bones marked by slowed winter growth. Insulation mattered here. Feathers on small theropods, possibly filamentous coverings on some ornithischians, warmed bodies through long nights when hunger and cold conspired. Behavior, too, is caught in the net of stone. Trackways with parallel lines speak of herds traveling together. Circles of footprints around nests suggest vigilance and the passing of shifts. Bone beds of single species tell of collective movements ending in flood or drought. Healed fractures are proof of lives lived beyond injury, of social bonds that allowed survival. In hadrosaurs, the alkaline of the dental battery and the growth of jaw muscles left marks where skin and flesh once held power. In ceratopsians, the sparring scars and patterned growth lines in frill bones sketch rites of maturity and breeding. The oviraptorids, once maligned as egg thieves for their proximity to nests, have been recast by posture and embryology as doting guardians of their own clutches. In coprolites, fossil feces, the crushed remains of plants reveal digestive partnerships, and gastroliths, smooth as river stones, tell of stomachs that ground fiber into fuel. Even in the grandest of herbivores, the daily economies of life can be felt. Fast replacement of worn teeth in sauropods, long growth, punctuated by pauses inscribed in bone. By the late Cretaceous, the continents had assumed a form that a modern map might recognize. North America was split by the western interior seaway. South America and Africa had parted. India hurried east like a seed under wind. Australia and Antarctica wore conifer canopies and fern floors beneath light that went missing for months. Faunas diverged under isolation. Gondwanan titanosaurs browsed the open and the forested, some small as bulls, others among the largest land animals to have ever lived. Abelisaurids and titans kept an ancient rivalry alive across arid flats and seasonal rivers. Laurasian plains, meanwhile, flourished with hadrosaur diversity and horned forms whose frills morphed wildly from region to region, like language-crossing mountains. Tyrannosaurids patrolled the northern latitudes, not exclusively lone hunters, and not necessarily pack killers either. The evidence is fragmentary and ambiguous, and science honors that ambiguity, leaving room for behavior's complex palette. Pterosaurs still soared. Birds had infiltrated every available habitat, from shorelines to forests to the interior of the sea, their skeletons telling of a slow drift toward the modern crown. At the apogee of this complexity, the clock struck an hour that left a scar the size of a country. 66 million years ago, a bolide, 10 to 12 kilometers of rock and metal, fell from the indifferent dark and struck the Yucatan. In a fraction of a second, rock behavior shifted from brittle to fluid. The crust rebounded. The gulf heaved. Shocked quartz formed under pressures that can only be imagined. Droplets of molten stone solidified into spherules as they rained across the planet. An iridium-rich boundary layer settled like a thin, continuous epitaph. Tsunamis raced outward. A global haze of dust and sulfate aerosols dimmed the sun. Photosynthesis faltered, temperatures plummeted, then swung. Some regions burned as ejecta heated the upper atmosphere and ignited what was waiting. Elsewhere, acid rains fell and soils screamed with chemical change. In the pollen record, a sharp fern spike, the opportunus of vegetation, marks the moment forests turn to ash and then to green shoots. Marine food webs balconied off into emptiness as plankton starved and the predators greater than hunger itself went quiet. Mosasaurs and plesiosaurs sank forever. Pterosaurs fell. Ammonites, so wide-ranging and resilient over previous catastrophes, ended in a conclusive hush. On land, the non-avian dinosaurs reeled and were gone. What endured did so as much by chance as by portfolio. Animals small enough to hide and wait, generalists that could eat a long list of lesser meals, creatures near water or in burrow or under cover. These survived the shock and cold and famine. Crocodilians persisted. Turtle shells weathered the night. Myriad lizards and snakes wrote the next sentences. Among the dinosaurs, one slender branch held tight. The birds. Not all birds, and not all at once. Many lineages failed together with their cousins. But somewhere in thickets near water, or on open ground scanning charred seed, a group of crownward birds survived, perhaps aided by beaks that could crack stored food, by intestines and gizzards armed with stones and grit, by an ability to fly when others ran and to huddle when flight was ruin. Their bones bear the same hollow trusses that once supported behemoths, their lungs the same through-flow engine that once fed a body the size of a house. In them, the heartbeats of the Mesozoic did not stop. They transformed. When the light returned, it revealed a world far smaller but ready again to expand. Mammals radiated into shadowed niches that were suddenly sunlit. Flowering plants staged comebacks and new invasions. Grasses would later arrive and transform entire continents. But in the branches and in the sky, the last living dinosaurs learned new songs, some with voices that loomed over savannas, some that whispered through the understory. The stones did not stop speaking. In Patagonia and China, in Mongolia and Montana, in Morocco's phosphate mines and Poland's chalk, in Australian floodplains and Arctic shales, the archives continue to grow. Eggs and embryos, skin impressions with the fingerprint-like ridges of scales, feathers mapped to pigments, footprints that recount a morning's path to water. All of it a record not merely of shapes, but of life itself. Tooth microwear, oxygen isotopes from enamel, carbon from ancient leaf cuticle, growth rings in bone and tree, pilots' instruments for time travelers. Looking back from this final chapter, the arc is immense. From the lean, fast pioneers that stepped past the Triasic's phantoms, through the Jurassic's pageant of oxygenated lungs and elevated hearts, to the Cretaceous with its flowering revolutions and divided continents. This is the story of invention under pressure, of retooling the same skeletal blueprint into whale-sized grazers and jewel-toned hunters of beetles among leaf litter. The titans we named were not born only of size. They were born of strategy, lungs that turned air into advantage, skeletons that traded mass for architecture, teeth that collaborated, crests that spoke, horns that negotiated, feathers that warmed, displayed, flapped, and ultimately flew. Their predators rose to match them, and their seas and skies filled with answers to the riddles posed by gravity and water and wind. When the sky fell, it ended many answers and preserved others as questions in the record. We live among the echoes. On winter mornings, turkey vultures draw thermals and write cursive across the cold. Shorebirds recalibrate for storms the way ancestors once recalibrated for seasons. The thrush on its branch, the hummingbird blurring the air, the heron slicing the wind, the penguin coursing beneath the ice. Each is a footnote to a history so grand that our own species appears near the last page. In museum drawers, a rib with its pneumatic foramen listens in silence while children pass and wonder. On a desert floor, a line of tracks, toe pads pressed neatly, crosses a dried riverbed and ends in sand that never saw rain again. Science is the discipline that takes these fragments and, with humility and care, uses them to ask better questions. In its hands, facts become narrative, stones become voices, ages become moments we can almost touch. The birth of Titans was never a single dawn. It was the long emergence of possibilities, the widening of the allowable into the real, the slow march of breath into bones that could raise heads above forests and into wings that could lean on the wind. Their reign concluded in violence, but its legacy is not merely an ending. It is continuity, distributed into forms everywhere. We stand at the shoreline of their time and trace their passing with palms outstretched to the spray. Once here was a world louder than thunder, heavy with steps, urgent with calls. Now, on quiet mornings, if we listen, we can hear it again, in feathered bodies that navigate a sky their ancestors opened, and in the rocks that remember how the giants were born, lived, and bowed to the next chapter. In the hush after cataclysm, the world exhaled ash and possibility. A thin clay seam, iridium-rich, seeded with shocked quartz and spherules, cuts the rock record, marking the night noon turned to winter. Charcoal and a fern spike follow, the first green rally on sterilized soils. From burrows and the forest floor, survivors filled emptied gills. Crocodilians lingered in rivers, turtles shouldered domes, squamates uncoiled, and the last dinosaurs, birds, took the air anew. Through the Paleogene canopies knit, reefs revived, climates swung, inscribed in isotopes, from early chill to Eocene greenhouse. Mammals rose by increments, placentals and marsupials branching, hoofed lineages drumming plains, bats claiming dusk, and whales, land-born artiodactyls, reforged as ocean titans. Birds radiated too, fanning the legacy of flight. Rocks archive recovery, pollen curves and oxygen arcs, a patient ledger, yet in every feather vein beats a theropod heart. The dinosaur story did not end. It modulated.